All right, I got the Ryobi 40 volt power station and just wanted to talk about some of the pros and cons that I've come across. First thing, I've got the Bluetooth hooked up on the Bluetooth app for the Ryobi generator control. It works on the actual inverter generators and it works on the battery power stations. And it has a timer, so you can adjust that you want it to turn off automatically, which is kind of cool because it'll cut back on standby power. Like if you have, as you can see here, with the AC side, it's 24 watts standby power. If you have just the unit turned on, which automatically turns on the USBs, it's 1.4 watts, which is a lot better than some of the competitors, including the Ego power station I recently looked at, which was 7.2 watts. So if you're charging a phone at 8 watts and you've got 7.2 watts of standby power, like on the Ego system, you're only getting half of the capacity of the battery that you could have got. So, and there's no particular reason why the standby power should be that high, and you can see that is proven right here. The Bluetooth app is nice. It lets you see how many hours that the generator has run, and also it shows the load level just like you see on the screen here, but you can check it on your phone, which is nice. You can also turn on and off the light, turn on and off the AC, and you can turn on and off the display. It's a 1600 watt continuous, 1800 watts for 3 seconds, 3000 watt surge. I tested it on my half horsepower Gould's water pump, which is 10.5 amps, but to turn it on, it's over 25. To get it started, it's over 25 amps. This unit had no problem starting that. Could it start a 3/4 horsepower pump? I honestly don't know. I suspect it probably would because it didn't even struggle to start the half horsepower, and there's not that much difference, to be honest, between the half horse and the 3/4 horse. On the DC side, you can see we got a couple of USB-C. It's not specifying the PD power delivery protocol, and I did notice that when I plugged in from on the regular USB and on the USB-C, I ended up with the same charging speed either way. So maybe that lack of protocol has an effect in that way. But the truth is, I don't really like to charge my phone on super fast charging, so that's okay by me. You can see I've got 4 6 amp hour batteries in here. Those are incorrectly labeled as 40 volt lithium. It's actually 36 volt nominal. So, but the cool part is they actually took that into account when they calculated the watt hours. So it says 216 watt hours instead of 240, which is accurate. So you've got a total of 864 watt hours, I believe. Although now Ryobi has 8 amp hour and I think maybe even 12 amp hour options in this size too. These batteries, these 6 amp hours, are actually 3 rows, which is why they're so big. It's 3 rows of 10 in series. One of the things I really like about the Ryobi 40 volt system is that it gives you an external cradle for when you're charging, which gives with an AC to DC adapter that's external. So they expose the DC side. As you can see, this little port right here is exactly the same as the port on the cradle. And you can see here, 42 volts, 1.5 amps, it's about 65 watts, which is very slow compared to what you would expect for a battery that size. But again, I don't mind charging those slow. And there's no particular reason to supercharge a battery to blast it unless you have a shortage of batteries and you really need to get them charged back up, like if you're snow blowing or something. And then of course they do have fast chargers for that are, I think they're 180 watts or 240 watts, something like that. And I have a couple of those. I never use them. I always prefer to charge slowly if possible. Now, because they give us that cradle with an external DC, you can actually take the wire and cut it right off of the converter. I would not necessarily recommending you do this, but it's possible to do. And now you have a universal plug here. So what you can do with that is you can use this. Now I've just put some slide connectors on there, some heavy duty connectors. And what you can do is you can hook that up to a DC-DC converter and you can charge the batteries directly DC to DC from your solar battery bank. If you have 12 volt, 24 volt lithium iron phosphate or something like that, you can also use an MPPT charger like this one. I think this is like 35 bucks. I got it on eBay. Input voltage is 50 volts. So that means you could use up to a 400 watt solar panel. Even if it wasn't getting hit by sun, it's going to make some power and charge up a 40 volt Ryobi battery. And of course there are advantages by charging DC to DC. If you have, in order to make a little battery charger, you want to program it for 42 volts. And that one I just showed you, that MPPT has programmability, so I was able to program it for 42 and verify that it was at 42. But because you have on a DC to DC converter, you have a little pot for adjusting voltage and a little pot for adjusting current. It's not just because it has those two adjustments, it actually dings your efficiency a little bit. So you might get something like 88% efficiency on that DC to DC conversion, which is still a lot better than going from like a solar panel DC, going through an MPPT converter, which is DC to DC conversion. You got some losses there into the battery. From the battery to the inverter, you have a 10% loss there. And then from the inverter, it goes up to a charger that's AC to DC to charge the battery. So you have another loss there, and that can be significant. That one can be like a ding of 20% or 15-20%. So you avoid all those conversions if you can go just DC to DC. Well, you don't avoid them all, but you avoid some. And if you charge directly through an MPPT charger with a panel, you avoid even the MPPT conversion. Anyways, the point is I like that they gave us that option. That way we have a cradle that we can access, and we can get the DC wire we can access. So that's a nice advantage. I don't think anybody's going to be too excited about 65 watt charging capability, but technically it can be done with a solar panel, and that's pretty cool. I do not believe this system can handle pass-through charging, so that's a major difference between this and a standard power station like a Blue Eddy, along with the fact that you're paying for having removable batteries basically, whereas you're going to get more bang for your buck on the Blue Eddy plus lithium iron phosphate, but the difference is you don't have removable batteries in those systems. Another thing that I like about the standard power station that this doesn't have is a 12-volt socket, and I can understand why they didn't put it there. It would complicate the situation, but if you have a 12-volt cigarette style plug, you can use something like this, so you can you have sort of future proofing, because if you have to change protocols, you can swap this doodad, and there you go. You got this is 120 volt potential on a 12-volt outlet. You have 120 volt potential there. So by giving you a port like that, it gives you the ability to keep up with the times, and this doesn't have that. So that's another thing that you would find on a standard power station. And this cigarette style is also important for being able to charge drone batteries DC to DC. With the power station like this, you would have to use the AC to DC converter. So you're adding you're going from DC to AC to DC again. So unless you already have the batteries, you're probably better off buying a Blue Eddy style power station. But if you do have the batteries, this thing is pretty cool, especially if you can get a deal on it. If you have any questions, please post them up. Thanks, guys.